Hello friends, in this video I'd like to solve the following problem from the Vietnamese Mathematical Olympiad 1991, problem number 1. We wish to find all functions from the set of real numbers into itself, satisfying the following condition. 1/2 f of zx plus 1/2 f of xy minus f of x times f of yz greater than or equal 1/4 for all real numbers x, y, and z. So functional inequality this time. This problem, to be honest, is not very difficult, so you may wish to try it yourself without my hints. But if you wish to see my hints, here they are. It's all about setting particular values. Start with setting x, y, and z to be 0, then set x, y, and z to be 1, then try setting just x to be 0, and finally try setting y and z to be 1. So give this problem a try and I will see you in a minute. Okay, so maybe let's start with setting everything to 0 as I suggested. And what do we have? Well, if I set everything to 0, I have 1/2 f of 0 plus 1/2 f of 0 minus f of 0 times f of 0, so it's f of 0 squared, greater than or equal 1/4. Very well. And now let's write it in the following way. Minus f of 0 squared plus f of 0 minus 1/4 greater than or equal 0. Let's remove our minus. So we have the following, and now we see, or we should see, the following formula. It's f of 0 minus 1/2 squared. Well, it's non-positive. It can be only equal to 0, it cannot be negative, so it means that f of 0 equals exactly 1/2. Exactly 1/2. Very well, so now we know something. And now let's try setting x, y, and z to be 1. We will get something very similar, namely 1/2 f of 1 plus 1/2 f of 1 minus f of 1 squared greater than or equal 1/4. And you should convince yourself that after very similar steps, f of 1 minus 1/2 squared is less than or equal 0, which again implies that f of 1 must be equal 1/2. Okay, so now we know something about our function. Next round of setting some variables. Next, I wish to set just x to be 0. Just x to be 0. Well, here is my equation, and I will set just x to be 0. And I will have 0, 0, 0. It was y in here, okay? And now we know that f of 0 is 1/2, so I have 1/2 times 1/2, 1/4, plus 1/4, minus 1/2 f of y times z greater than or equal 1/4. Well, and that means after some simplifications that f of yz is less than or equal 1/2. And remember that is true for all real numbers y and z. Okay, and now maybe I will move it a little bit to the left. Very well. And finally, try setting y and z to be 1. Let's set y and z to be 1. And we will get the following. 1/2 f of z times x, but z is 1, so 1/2 f of z, 1/2 f of x, plus 1/2 f of x again minus f of x times f of 1 is greater than or equal 1/4. And what do we see? Well, here we have f of x. F of 1 is 1/2, 1/2. So it's 1/2 f of x is greater than or equal 1/4, which of course means that f of x is greater than or equal 1/2. And that is true for every real number x. Very well, but now let's look at it. Our function should be always less than or equal 1/2 and always greater than or equal 1/2. And that can mean only one thing. From this and this, we have only one possibility, namely f of x must be constantly equal 1/2 for every real number x. Okay, so it's the only possible solution. Is it really a solution? Well, let's go back to our condition. If I put 1/2 instead of every occurrence of f, here I have 1/2 times 1/2, 1/4, plus 1/4 is 1/2. 1/2 minus 1/4 is 1/4. 1/4 is equal to 1/4. So yes, it does satisfy our condition. So that's it. Our functional inequality has just one solution, function which is constantly equal to 1/2. Thank you for watching and I will see you next time. Goodbye.